Hello guys, my name is Singh. My registration number is 15bce0106 and this is a video telling you about my IoT project, uh, about my IoT DA, explaining the leap motion device to control an anthropomorphic gripper with 5 fingers. First, a description of the leap motion device. It is presented highlighting its main functional characteristics, followed by testing of its use for capturing the movements of a human hands in different configuration. So in this I'll explain why I took these two IoT devices and then combined it and what's my basic idea behind this. But first let me tell you about the concept model and the pros and cons, etc. Using the leap motion to detect the human hand, it was a complex capturing all the complex gestures. First, compared to the Microsoft kernel sensor, which is not taken in this case because due to a distance of less than 1 meter, the the problem starts coming in. The sensor starts weakening. So one great advantage of this leap motion as compared to its predecessors is that it can distinguish each fingers individually, which is a very important factor in my TA. So the identification algorithm attaches to each finger gesture and a hand a unique identifier to make changes, etc., to basically give each finger its own identity. So how we did this, the screen glass describes the user's monitor position. It captures and orients all the movement, etc., of the hand so that we can put it in the gripper. So this is done by a camera and a small motion detecting device. So the interaction box, this is very important. Glass is a rectangular area above the leap motion device which is visible into full ladder. The leap motion coordinate system can be mapped to a point relative to a volume represented by interact box class. So this is where the main capturing of the movement takes place. So for for the configuration of the leap motion sensor parameters, the configuration class is important. This is employed. This class permits access to the physical configuration for the leap motion device. So this has been explained. Now basically it's a human hand. There is a motion leap device which takes the movement from the hand, the command and the control software modules which convert all this to a robo commander hand. So I can show you the way this was the flow chart of how this takes. So for the construction part, beginning by connecting the PMW driver, that's the driver corresponding needed for this, to the Raspberry Pi, and then servers to the PMW driver. So the external 5V power is needed for the servers required. The Raspberry Pi can't draw enough power to power all. So now about the hardware, by connecting the PMW driver, the driver needed for this, to the Raspberry Pi, and then we connect a 5 volt power source because the Raspberry Pi is not capable of powering all the sources, all the objects and the grip and all. So we take a 5 voltage extra power, and then we have different channels, all the channels giving what instructions are needed, etc. So this is a whole schematic of how it works. The pros and cons. The great thing about the product is its sleek and small design. It outpowers it powers the already existing Microsoft Connect and other softwares. There are many pros and cons to this, like the disabled people can use it, and it is a for some very extreme and hard. So there are many pros and cons. The extreme hardware and etc. For extreme climate and stuff. This can be used for experiments which we cannot uh, be there present there physically. We can use this robotic hand and put all the gestures in it. The basic idea behind this is that I took two IoT devices. I took two normal devices. One is the leap motion and second is the gripper, the robotic hand. And the main IoT part I did was to connect these two. Earlier, the robotic hand, we put commands in it, we coded. The instructions are already filled and installed in it, so we cannot make changes, and it's already pre-installed, so it would be commanded what to do. But with putting the leap motion proposal behind it, we can make it work simultaneously and achieve further goals. So all this combined tells us that the leap motion, the future tech, the think the reason now, the technology behind everything would now be controlled using leap motion only, because it's better. It's We don't have to touch, we don't have to use a desktop or a mouse or anything. We can do it by hand gestures and with the distance only. So combining these two will give us a lot of future advantage, and we can excel in military grade and chemical part also. So the basic reason behind this was this only. Thank you.